Ever wondered how AI knows that cat and dog are similar, but cat and car are not? The secret lies in vector distance, the mathematical way AI measures how close or far two ideas are in its world of numbers. From words to vectors in AI, everything, words, images, users is converted into vectors, which are a list of numbers called embeddings. Each vector represents meaning, like a location on a giant map of ideas. The vector distance tells us how close 2 points, ideas, are on this map. Small distance, very similar meaning. Large distance, unrelated concepts. Let us take an example. Here, we will use vectors for cat, dog, and car. You can imagine these numbers as coordinates on a map. Cat, 1, 2. Cat is at one spot, like a small house at location, 1, 2. Dog, 2, 2.5. Dog is nearby, maybe another house at 2, 2.5. Car, 10, 8. Car is far away, like a building across town at 10, 8. So on this map of meanings, cat and dog are close together because they're both animals. But car is far away because it means something completely different. That's how AI knows that cat and dog are related, not by understanding language like we do, but by measuring how close their number locations are in this invisible map. Let us now see how AI measures distance. Not all distances are the same. AI uses different methods depending on the type of data and context. Common types of vector distance metrics that AI uses are: 1. Euclidean distance, the straight line, as the crow flies. Great for images. 2. Cosine similarity, measures angles, not length. Perfect for text meaning. Example: AI and artificial intelligence point in almost the same direction. 3. Manhattan distance, city block walking. It is good for structured data. It is good for comparing product prices or ratings. 4. Hamming distance, counts differences. Ideal for binary data or DNA. 5. Jacquard distance, compares overlaps. For example, 2 new articles sharing 80% of the keywords. Let's now compare two vectors, for example, cosine versus Euclidean, A equals 1, 2, B equals 2. Now, there are two ways to compare how similar these arrows, ideas, are. Euclidean distance measures how far apart the arrow tips are. Think of it as the actual distance between 2 points. In this case, they're about 1.4 units apart, not far, so they're somewhat similar. Cosine similarity measures the angle between the two arrows. If two arrows point in almost the same direction, the angle is small. They have similar meaning, even if one arrow is longer. Here, the angle between A and B is tiny, giving a value of 0.983, meaning they're very similar in direction. Cosine focuses on meaning, not magnitude. That's why it's the preferred method for language models and search engines. In a nutshell, semantic search, ChatGPT, Google, etc., cosine similarity. Image recognition, Face ID, visual search, Euclidean distance. Recommendation systems, Netflix, Spotify, cosine or Euclidean. Fraud detection and biometrics, preferred distance method to use is Hamming distance. Content tag matching, preferred distance methods to use is Jacquard distance. So, every time you get a spot on YouTube suggestion, a perfect product match on Amazon, or an accurate ChatGPT answer, you're seeing vector distance in action. It's how machines understand relationships and meaning between ideas. Want to learn more? Like, share, or drop a comment if you want a part 2 diving deeper into embeddings.